In this lesson, we'll talk about the inverse trigonometric functions and how to take derivatives with these. First off, we've got our definitions, and you've worked with the inverse trig functions before. I'm not going to spend a lot of time on this slide. I'm just going to point out that what it means for all of these is the inverse function is the one that undoes the original function. If you're talking about the inverse sine of x equals y, you're looking at the angle whose sine is x. So y is the inverse sine. Y is the angle whose sine is x. The one thing that does have to be used with these, and I'll show you this on the picture, is that these domains have to be restricted on some of these. Otherwise, the functions are not one-to-one, and we run across some trouble. I should point out this is the inverse sine, inverse cosine, and so on. There is another notation, but this is the one that I prefer. I think it works the best in general. The negative 1 is not an exponent. It does not mean 1 over sine x. It means the inverse sine of x. With that said, here's your picture. We've got the other notation, the arc sine, arc cosine, but I will always use inverse sine, inverse cosine, and so on. You'll see some pictures here of what the inverse functions look like after certain domain restrictions have been made. Let's focus on what we want to do with these. The derivatives of the inverse trig functions. You should definitely get these written down somewhere. Here's all the rules for taking the derivatives of each of the 6 inverse trig functions. Some things you'll notice is that the co-function is identical to the original function in its derivative, except for a negative sign, something that might help you in your process. Let's do an example. For this one, we've got the inverse sine of u. So I'm going to be very careful here. The inverse sine of x is 1 over the square root of 1 minus x squared. But I'm thinking like u squared, so I really just get x cubed squared. So in this formula where I have an x, I'm now using x cubed. But by the chain rule, I also have to multiply by the derivative of the inside. So I get 1 over the square root of 1 minus x to the 6th times 3x squared. Next one, inverse tangent of square root of x. The rule for inverse tangent is 1 over 1 plus u squared, if you will. So where I have an x in the formula, I'll use square root of x instead, times the derivative of square root of x. So I get 1 over 1 plus x is what the square root of x squared becomes, times the derivative of square root of x, which is 1 over 2 square root of x, and I'll just leave it like that. Next one. We've got the inverse cosine of x raised to the 4th power. This time we're still using the chain rule, but the 4th power is the outside function. So I'm going to start with u to the 4th and get 4u cubed times the derivative of the inside. So I get 4 inverse cosine of x cubed times the derivative of inverse cosine of x, which is negative 1 over the square root of 1 minus x squared. Next one. The outside function is the natural log. So we'll start off with the rule for natural log, and this one actually is going to be a little bit complicated because there's 3 parts, but that's okay. The natural log rule is 1 over the inside times the derivative of the inside. Let's continue. I'm going to copy this. That part's done. The derivative of the inside is the cotangent rule, which is negative 1 over 1 plus e to the x squared. But technically here we're still using the chain rule times the derivative of the inside. I was doing inverse cotangent of u, so I still have this set up. Just to finish it off and write it cleanly, or as clean as we're going to, we have this times negative 1 over 1 plus e multiply my powers to get 2x times the derivative of e to the x, which is e to the x. Two-part chain rule.